Hey everyone! Have you ever stared at a chunk of code and it just felt, like a magic trick? Well, today we're going to pull back the curtain on Python. We'll show you the simple, clever logic behind some classic coding puzzles. Let's dive right in.
Right? You see something go in and something else comes out. But what happens in between? It can feel like a total black box. Well, we're about to crack that box wide open.
But here's the big secret. All that magic is usually just a bunch of simple, logical steps, all strung together. And that's exactly what we're going to prove today by breaking it all down. So, we've got 3 classic puzzles lined up for you. Think of it like a little workout for your coding brain. And I promise, by the end of this, you'll see that it's not magic at all. It's just really, really clever logic.
Okay, first up, we're tackling a real classic, the palindrome checker. This is a perfect place to start because it shows off a super cool, kind of sneaky Python trip. So, what exactly is our goal here? Simple. We need to figure out if a word is a palindrome. A word that's a perfect mirror image of itself, like madam or race car. Our job is to write a little piece of code that can spot one instantly.
Okay, here it is. The whole solution, right there on the screen. It might look a little intimidating at first glance, but don't worry. We're going to break this down piece by piece. All right, focus in on this one line right here. This is where the Python magic really happens. It's a neat trick called string slicing. That little squared bracket / one thing, it's basically a super powerful shorthand that tells Python, hey, take this whole string, but walk through it backwards. And just like that, you get a reversed copy of the word. No fuss, no complicated loops. Pretty cool, right?
And once you've got that reversed word, the rest is honestly the easy part. You literally just check if the original word is the same as the new reversed one. If they match, boom, it's a palindrome. If they don't, well then it's not.
And here you can see it in action. We give it race car and it comes back true. We give it Python and it says false. It works exactly like it's supposed to. Awesome. 1 challenge down, 2 more to go.
Okay, let's keep that momentum going. For our second challenge, we're going to step it up a little and find the largest number in a list.
But there's a catch. See, Python actually has a built-in max function that would do this for us in a split second. But that's too easy. To really understand what's going on under the hood, we're going to build this thing from the ground up ourselves.
All right, take a look at the blueprint. This is our find max function. Yeah, it looks like there are a few more moving parts than our last one, but I promise you, the main idea behind it is just as straightforward.
So, how do we even start? I mean, you have to begin somewhere, right? Well, the code does something really simple. It just assumes the very first number in the list is the biggest one. For now, think of this highest variable as our reigning champion, waiting to be challenged.
Okay, let's actually walk through this with an example. The list 10, 50, 20, 5. We start off by saying our highest is 10, because it's the first number. Then the loop kicks in. It sees 50. Is 50 bigger than our current champ, 10? Oh yeah, so we crown a new champion. Highest is now 50. Next up is 20. Is 20 bigger than 50? Nope, the champ stays. Finally, we get to 5. Is 5 bigger than 50? Definitely not. The loop ends, and we're left with our final, undisputed champion, 50. See, it works. All right, time for our final challenge. This one's a classic from math class, calculating a factorial. It's all about multiplication and keeping track of a running total. So first things first, what even is a factorial? You'll see it written with an exclamation mark, like 5fac. All it means is you take that number and multiply it by every whole number all the way down to 1. So for 5 factorial, it's just 5 times 4 times 3 times 2 times 1, which gets you 120. And here's how we can write that in Python. Now take a look, you might notice this looks kind of familiar, right? It has a really similar structure to our last problem. We set up a variable to start, and then we use a loop to build up our final answers step by step. Let's actually watch how this result variable grows. We kick things off by setting it to 1. And, quick question, why 1? Well, think about it, if we started with 0, anything we multiply by it would just stay 0, so we start with 1. Okay, now the loop starts. First it's 1 times 1, which is 1. Then our result, which is 1, gets multiplied by 2. Now we have 2. Next, that 2 gets multiplied by 3, giving us 6. Then 6 times 4 is 24. And for the final step, 24 times 5 lands us at 120. That's our answer. This idea of building up a value inside a loop is called accumulation.
So let's step back for a second.
What have we actually learned here? If you look at all three puzzles, we've basically been using the same core tools from our programming toolkit. We learned how to set up or initialize variables to give ourselves a starting point. We used loops to run through data again and again, and we used if statements to make decisions along the way. These three things, they're the absolute building blocks of so much programming.
So there you have it. You just walked through 3 classic coding puzzles and really sharpened that logical thinking muscle. The big question now is, what's next?
Well, if you're looking for a suggestion, here's a great one. It's a problem called FizzBuzz, and it's super famous as a technical interview question. Why? Because it's the perfect test of the exact skills we just practiced, loops and if statements, working together.
Look, you've seen today that what looks like a complex problem, or even magic, is really just a series of simple logical steps. The mystery's gone, and what's left is understanding. So really, the only question left to ask yourself is, what puzzle are you going to solve next?